wabarakatuh. My name is Muhammad Ishraf bin Abdul Razak, and this is my group member, which is Afiq Anwar and Afiq Shazwan. Uh, uh, will explain about our project about car parking sensor. Next slide. Okay, in this slide, we will explain to four part, which is introduction, methodology, result and discussion, and also conclusion for these projects. Next. Next is the introduction for this project. The first one. Introduction, a car parking sensor is a piece of technology that detects or sense an object and alert the driver to potential hazards. This technology is also known as a driver assistance system. The feature have been gradually improved to assist the driver in monitoring the car blind spot by measuring the distance between the bumper and the obstacle by using sensor. Next. Okay, this is our primary objective, which is to create a car parking sensor system that will assist the driver while in the parking mode. The second one is to keep a driver from becoming tired while park the car. And the third one is to identify an impediment when parking using an infrared distance sensor. Next one, I will pass to my group member, which is Muhammad Afiq Shazwan, for the methodology.
I will explain to you about the methodology. This is the flowchart. The flowchart will start and we turn on the clock of ADC1 to GPI and GPI OAB. And we set the switch 1 and 2 at GPIOB. If the switch 1 is pressed, the motor's driving forward and the virtual terminal will display car is driving forward. If switch 2 is pressed, the motor driving will reverse. And then it will go to N. After that, the sensor will read the analog value and convert to distance in centimeter, and it will it will calculate the voltage 5 times analog value divided by 4096, and it will also calculate the distance, and it will print the voltage and distance value at the terminal display. We go to the next slide. Then it will when the distance is more than 60 centimeter, the motor driving will reverse and message warning will appear at the display panel. And if no, when the distance is more than 25 centimeter and below 60 centimeter, the motor driving reverse message will warning you that the car are closing, and the LED will blink with the 50 millisecond delay. If the distance is less than 25 centimeter, the motor driving reverse message for the car to stop, and the LED will blinking, and it will delay 0 millisecond, and it will end. I will show to you the block diagram. The block diagram for the car parking sensor project is shown in the slide. 4 DC motors are employed as an output. As illustrated in the block diagram, 2 switches are used as inputs for reverse and forward, and 1 GP2D12 distance sensor is used. The power supply and battery are the project's power system. In the block diagram of an automobile parking sensor, the STM32F103 microcontroller is the controller that delivers the output of the DC motor motor, and LED, which we call light emitting diode. That's all from me. I will pass to my friend Afiq Anwar.
Mic no mic. Mic.
Anwar buka mic.
Tak
Oh,
boleh
sorry
cut,
guys. Okay, my name is Afiq Anwar Bekmal and I will present about this design of the project. So this is our design for project in a purchase that we designed. Okay, next. And then I will show about the result and discussion. Next. Okay, before I explain about the result, so based on the simulation on purchase and the embedded system on kill, all output function as desired. Push button 1 act as the pedal for forward drive of the car, meanwhile push button 2 act as the pedal for reverse direction of the car. When the push button 1 is processed, for motor will move clockwise. Meanwhile, when the push button 2 is pressed, the motor will move anti-clockwise. Okay, since the main focus on the distance sensor is GP2D12, the reverse pedal will be used more frequently. The GP2D12 will function to determine the distance from the car and the object. Okay, so based on the research on internet, a formula that convert the analog value of GP2D12 to voltage value and the distance in cm is found. Okay, so the voltage for distance by measure is given by the VR is 5 volt. Okay, so this is a result for more than 60 cm, less than 80 cm. Okay, the project is set when the car distance is 60 to 80 cm to the object. The warning message is sent through the serial monitor and 4 LED will be blink in 200 millisecond delay. If the distance is next. Okay, so if the distance is 25 to 60 seconds, it will show the warning you are closing. Message is sent to the driver and 4 LED will be blink in 50 millisecond delay. So meanwhile, if the distance is less than 25 seconds, next. This is the result of less than 25 seconds. The car will stop and the reverse pedal will not function anymore as the motor drive L2939 is already disabled. So the LED will light up without any blinking and the sounder will activate to give the signal to the driver. Okay, next. Next is about the discussion. Okay, so based on the analog value based distance graph that we generate using the data from the simulation, it shows that when the distance of the decreasing, the analog value will be increasing, meaning that the XTCM distance, the sensor will read 333 analog value and it will display warning to the user. When the car is 60 seconds below and it will away from the obstacle, the sensor will read 427 analog value and keep increasing until the net measuring distance. Okay, so I will pass to Muhammad Ishraf to conclude our presentation.
Thank you, Afiq Anwar. And now for the conclusion. Next slide. As the conclusion for the project, in this project, a new car parking sensor is implemented. The system can control the position of the car during parking, whether the car is parking properly inside the parking box or not, based on the distance sensor GP2D12. And second one, the movement of the car also been taken care of using push button to control the motor of the car. And the third one is the system boosts of efficient utilization of minimal usage. Along with this car parking sensor is very beneficial for the community who are hardly to get their car parking perfectly in the parking box. And the last one is the performance evaluation show that our system managed to give a detailed data during in parking mode, and overall the parking sensor is completely a success since it can achieve the objective of this project. That's all from us. Thank you.